Okay, now that we converted our backdoor and listener to use classes so that they're easier to extend, we are ready to start implementing new features in our backdoor. But before we do that, I want to spend some time talking about a common issue that you might face when transferring data over TCP. Now, as you remember, when we created our sockets in the backdoor and in the listener, we set the connection type to sock stream, which basically means that we want to create a TCP connection. So the way that TCP works is it creates a connection between two computers, and you can think of this connection as a pipe where the data is water flowing through this pipe. So the way the data is transferred between these two computers is as a stream, not as messages. So it's a stream-based protocol, not a message-based protocol. Now you might be asking, so what are you trying to say? Basically what I'm trying to say is, think of this as a pipe where every time the client wants to send something to the server, they add more data to this pipe, or they add more water to this pipe. So the data is all mixed up in this pipe, and when it's sent to the server is able to receive this data or this water, but it doesn't know where the end of each message is. So let me show you an example. Let's say that the client wants to send some long data as a message to the server. Now, as you remember, in the server, when we receive data, we call the connection.recv, and we're specifying that I want to receive 1024 bytes of data. So, even before receiving the data here, we are saying that I want to receive only 1024 bytes. So hence the small red box that we're already creating before we even receive the message. Then when the client sends this on the stream, as you can see, the whole data gets pushed in the TCP stream. So that's all fine so far. But the problem happens is once the data arrives to the server, once the server starts to drawing data out of this stream. So we're gonna take only 1024 bytes. So we're only gonna take enough data to fill our box. Now the server thinks that it received the data, but there is still a lot of data left in the pipe. Now the reason why the server doesn't know that, because like I said, every time the client wants to send something, they just push it in this pipe, in this stream. There is no way for the server to know where the start and the end of each message. Again, the main reason for this is because we're sending this stuff over TCP, and TCP is a stream-based protocol, not a message-based. So everything is mixed up in here. Now let me show you how this issue will happen in practice. So right here, I already have a connection from my backdoor, and if I just do dir, I'm in Zaid Python projects, and you can see that I have a file called sample.txt. Now, in Windows, we can use the more command to read the contents of a file. So let's say I want to read the contents of sample.txt. Now, if I hit enter, you'll see that I get the contents, which is perfect, but this is not the full content of the file. So let me show you. If I go to my Windows machine and open the file, you'll see that we're only reading up to this paragraph right here. So basically what's happening is the client, which is the backdoor in here, is placing all of this data on the TCP stream. But when this data arrives at the backdoor is only reading 1024 bytes. So it's only reading up to this point, and then it doesn't know that there is more data. Now what's going to happen if I hit enter? My recv method will be called again, and we'll actually receive more data. So you'll see we'll get the rest of the file, and if I hit it again, I'll get the rest of the file. But now I broke the connection, so if I hit enter, I'll get nothing, and if you wait for a little bit, you'll get a broken pipe exception. Now, this is actually a very important thing to fix because regardless of why you have a socket connection, let's say maybe you have that for any other reason other than using a backdoor, you're gonna face this issue every time you send data that is larger than the buffer size, which is 1024 in our program. Now you're gonna get this issue whether you're sending stuff from the server to the client or from the client to the server. And this issue will obviously get bigger when you try to implement more features. For example, we want to be able to upload and download files, and a lot of these files will be bigger than 1024, which again will cause us issues. And if you're writing a larger application, something other than a backdoor, then you'll definitely face this issue when you're transferring data between your client and your server. So before we dive into implementing new features in our backdoor, I want to address this issue so that you know how to properly and reliably send data between two clients over sockets. I'm going to keep this as generic as possible, and we're going to forget that we have a backdoor and a listener so that you can use this way regardless of what application you're writing, as long as your application uses sockets. Now, there are a number of solutions to fix this. Basically, the idea that you want to keep in mind is you need to make sure that the message is well defined, so that the device that's receiving this message knows exactly where this message ends. This way, even if it receives half of it or part of it, it knows that there is more to this message, and it'll call the receive message again and again until it actually receives the whole data. So, ideas of doing this: you can, for example, measure the size of the message before you actually send it at the client, add this size to the start of the message, and then send it. When the server receives it, it can read the size, it knows exactly how big this message should be, and it'll keep receiving until the size of the received message is equal to the size of the sent message. The second way of doing this, you could append something to the end of the message so that when this guy is receiving stuff, it'll keep receiving the message or removing stuff from the connection until it reaches this special end of message mark that you're gonna specify yourself. Again, you'll be adding this at the client before you send it, and once received, you're gonna have to make sure that you read the stuff up to this end and then remove this end so that you don't interfere with the message. And finally, which is the method that I want to use and implement, is using serialization. Now, serialization is very commonly used in programming, not only in Python, when we want to transfer data between two computers. The reason why this is very widely used is because, first of all, it fixes the issue that we have right now, which is our messages are not well defined. So using serialization, our message is going to be well defined and the receiver will know exactly where the message ends. It also has an added benefit, which it basically allows us to send data structures. So it allows us to send lists or dictionaries through our connection, which is something that we can't do right now. We can only send text, we can only send strings. Now, the way that serialization works is basically the client converts the object or the message to be sent to a stream of well-defined bytes. It puts that on the TCP stream. The server is gonna keep receiving stuff from the TCP stream, and once it receives everything, because it's well defined, it's gonna know when it has everything, and it's going to convert this back to the object that it was. So if we send a list here, we'll be able to receive a list here. If we send a dictionary, we'll be able to receive a dictionary here, and so on. So basically, the way that this will work is going back to the same example that we were talking about. So let's say that the client wants to send a message that says sample long data to send over TCP stream. It's going to put all of this message. So this could be a normal string, this could be a list, this could be a dictionary. Regardless of what it is, it's going to put it inside a box. So you can think of this as a package or a box. Then it's going to close this box and put this box in my TCP stream. Then, because this is a box, because this is well defined, the server is gonna receive data, and it will only stop receiving data until this box is complete. We still don't know what's inside this box, we just know that this box is complete. Then the server is going to unbox this box and it will be able to retrieve whatever that was inside this box, whether it's a message or a string or a list or an object or any other data type. So you can see that this is a very simple and useful way of transferring data between a client and a server. It allows us to make sure that the message is sent and received properly, and it also allows us to send data structures like lists and dictionaries, which is very, very important when we want to do more complex stuff in our program. So in the next lecture, we'll see how we can put this in practice, and then we'll start using it in order to extend our backdoor and implement more features.